Math is clean, math's easy when you're doing math with Miss Lee.
Welcome to the lesson on factoring trinomials. In this lesson, I'll give you some strategies for organizing your work when using the classic trial and error method. I'll begin by finding factors of the first term, 6x to the 6th. Although x to the 6th can be split in a variety of ways, it makes the most sense to break it into x to the 3rd times x to the 3rd because the middle term is an x to the 3rd. The coefficients must multiply to equal 6. This gives me choices of 1 and 6, or 2 and 3. I always recommend choosing the factor pair that's closest together in value in your first attempt. So let's make those 2x to the 3rd and 3x to the 3rd. One of the biggest mistakes students make with factoring trinomials is to work sequentially, so to work on the middle term next. Instead, what you should really do is to work on the last term next, and then deal with the middle term last. Those last two positions need to be filled with factors of -12. Although this method requires some guessing, I can make some educated guesses from here. Since there were no common factors in the original problem, the factors themselves should also not contain common factors within them. So that means I cannot place a multiple of 2 in the parentheses with the 2x to the 3rd, because that would create a common factor of 2. I also cannot place a multiple of 3 in the parentheses with the 3x to the 3rd for the same reason. In that case, I can cross out the factor pair 2 and 6. They're both multiples of 2, so I wouldn't be able to avoid placing a multiple of 2 with the 2x to the 3rd if I used this pair. So I'll try the 3 and the 4 first. If 3 and 4 work, the 3 will have to go on the left and the 4 will have to go on the right to avoid making common factors within the parentheses. Next, to test this out, I'll multiply the outers and inners from FOIL to see if I can get the middle term to work. So the outer terms have a product of 8x to the 3rd, and the inner terms have product 9x to the 3rd. These must add up to the middle term, -x to the 3rd. To make this happen, the 9x to the 3rd must be negative, and the 8x to the 3rd positive. So to make 9x to the 3rd negative, the 3 must be negative. This makes my factors 2x to the 3rd minus 3 and 3x cubed plus 4. In my second example, let's factor 6x to the 8th plus 7x to the 4th minus 10. Begin by finding factors of the first term, 6x to the 8th. Breaking the x to the 8th into x to the 4th times x to the 4th. As in the first example, the coefficients must multiply to equal 6, and I'll try the 2 and the 3 first. Next, I'll try factors of -10 in the other two positions. Trying the 2 and 5 first. The 2 must go with the 3x to the 4th to avoid making a common factor. This makes the outer terms multiply to equal 4x to the 4th, and the inners make 15x to the 4th. There's no way to add a 4x to the 4th and a 15x to the 4th to make 7x to the 4th, no matter what the signs are. So the 2 and the 5 can't work here. Now try the 1 and 10. The 10 must go with a 3x to the 4th to avoid making a common factor. This makes the outers 20x to the 4th and the inners 3x to the 4th. There's no way to make 20x to the 4th and 3x to the 4th add up to 7x to the 4th, so 1 and 10 can't work. Since we've exhausted all the factors of 10, we need to go back to the beginning and try a different factor pair for 6x to the 8th. So starting over, I'll try 6 and 1 instead of 2 and 3 to make the first term 6x to the 8th. Then I'll insert the 5 and 2 to make 10, being careful not to place the 2 in the same parentheses with the 6. This makes the outers 12x to the 4th and the inners 5x to the 4th. 12x to the 4th plus a negative 5x to the 4th gives me 7x to the 4th. So the 5 must be negative, and I'll make the 2 positive. So the correct factors are 6x to the 4th minus 5 and x to the 4th plus 2.